नमस्कार बच्चों, मेरा नाम धन्या और वेलकम टू पार्ट 2 of past paper solving for the lesson on chemical bonding. Okay, in part 1 we learned about we solved around 14th question, and in part 2 we will start from the 15th question. Okay, now in the 15th question you have some molecules given to you and you have to choose which of them has a linear geometry. Okay, so in this, please remember that for a linear geometry, if any molecule has an sp hybridization and the lone pair is 0, then that means they have a linear geometry. If any molecule has sp3 hybridization and they have 3 lone pairs, that also will have a linear geometry. And if any molecule has sp3d hybridization and 3 lone pairs, they also have linear geometry. In fact, here they are talking about the shape. Okay, so let's start with the first one. It is sulfur dioxide. Okay, in sulfur dioxide, finding out the Z value hybridization. We have done a lot of questions based on finding the hybridization in the part 1 video. Okay, so it is half of number of valence electron in the central atom. There's no positive or negative charge, no monovalent atom. So that is 3. So 3 means sp2 hybridization. And sp2 hybridization, and also if I have here from this information given here, you can see sp2 is not a part here, but still let's check out the lone pair. So Z is equal to bond pair plus lone pair. Okay, so I have here 3 is equal to, so I'll just reduce the thickness of the pen. 3 is equal to, there are 2 bonds plus 1, so the lone pair, so lone pair is equal to 3 minus 2, 1. So sulfur has 1 lone pair and 2 bonds. Okay, and it doesn't have a linear shape. In fact, it has a bent shape. So sulfur dioxide doesn't have a linear shape. Okay, now the second one is beryllium chloride, BeCl2. If we talk about the Z, it has 2 electrons in the outermost shell and no positive or negative, but 2 monovalent atom. Z is 2, so it is sp, and lone pair is 0 because you can see Z is 2 and bond pairs is 2, so lone pair is 0. This comes in this category. So BeCl2 has a linear configuration. Coming to carbon dioxide, half of carbon is 4 in the outermost shell. There is no positive or negative charge. In fact, it is 2. 2 means sp hybridization, and lone pair is also 0 because there are 2 bond pairs and Z value is 2. So the lone pair is 0. So this also comes under this category. So carbon dioxide has a linear shape. Now, I have N3 minus. This is an azide. So this lesson, the lesson on nitrogen and amines, you will be learning in grade 12. And in fact, you can see here, I can calculate the sigma, or I can calculate the Z value from the sigma bonds. You can see here, the Z value is number of sigma bonds plus number of sigma bonds plus lone pair on the central atom. Okay, so number of sigma bonds is 2. The lone pairs on the central atom is 0. So Z value is 2. So that means it is sp hybridized. So there's no lone pair. So this also comes in this category. Lone pair is 0. So N3 minus also has this linear shape. Okay, now coming to the next one is, when you practice all these molecules, it's just memorized, so you can just quickly circle the correct answers. Okay, so here NO2, so in nitrogen dioxide, you can find out like this. Nitrogen has 5 electrons in the outermost shell, okay, and it forms a double bond with oxygen and single bond with another oxygen. So there's a sigma bond here, there's a sigma bond here, and one lone pair of electrons for the central atom. So Z value is equal to number of sigma bonds plus one lone pair, that is 3. 3 means it is sp2 hybridized, so it doesn't have a linear shape. Now coming to F2O. Oxygen is the central atom. I have 6 electrons in the outermost shell, 2 monovalent atom. And it is 4. 4 is sp3 hybridized. Coming to lone pair. So 4 minus 2. Z is 4, bond pair is 2. So the lone pair is equal to 2. So this doesn't, sp3 hybridized with 3 lone pairs should have a lone pair. With 3 lone pairs should have a linear shape, but this has 2. So this doesn't come in that category. The next one is XEF2, which is half of 8 electrons in the outermost shell of xenon plus 2 monovalent atom, that is equal to 5. So 5 means sp3d, and 5 minus 2 bond pairs, which is 3. So this comes in this category. So XEF2 has a linear shape, and NO2 plus. It is something similar to NO2, where the central atom has a positive charge. So there, usually nitrogen has 5 electrons in the outermost shell, but here it has a positive charge. So there are only 4 electrons. So it is forming a double bond with oxygen on either side. So how many sigma bonds are there? 2 sigma bonds are there plus 0 lone pair. So it is sp hybridized with lone pair is equal to 0. Okay. So this satisfies this condition. So NO2 plus has a linear shape. Okay. Now coming to iodine, I3 minus. Iodine is from group 7, so it has 7 valence electron. So out of the 7, iodine is forming 2 bonds. It will be a single bond because group 7. Now out of 7, 2 is used up to form the bonds. So I'm left with 1, 2, 3, 4, 5 electrons are left, but there's a negative charge, so that's corresponds to 1 electron. So I have 3 lone pairs. Okay, so 2 sigma bonds and 3 lone pairs, that corresponds to sp3 dehybridization with 3 lone pairs. 3 lone pairs. So that is why iodine has a linear shape. Then ozone. Oxygen has 6 electrons in the outermost shell. So oxygen has 6 electrons in the outermost shell. So Z is equal to half of 6, and there's no lone pair, and there's no surrounding monovalent atom, positive or negative charge. So Z is equal to 3. So sp2 hybridization. So having Z value 3 is equal to, there are 2 surrounding atom, 2 bond pairs plus lone pair. Lone pair is equal to 1. There is nothing that corresponds to here. So oxygen, this ozone doesn't have a linear shape. Okay, so these are the set of molecules that have a linear shape. Okay, I hope I'm clear. So these conditions you have to remember. Okay, coming to the 16th one. Okay. In 16th one, arrange the following compounds in increasing order of their dipole moment. Now, 16th one, there is HBr, there is H2S, there is NF3, and CHCl3. These are the molecules. Now, over here, if I draw NF3, okay, so in NF3, the Z value is 5 plus 3 monovalent atom by 2, which is equal to 4. So sp3 and 4 minus 3 lone pair is equal to 1. So it has 1 lone pair. Okay, and this is the dipole. This is dipole. This is dipole due to the lone pair. So although they are in the opposite direction, mu and mu dash are not equal, so they don't cancel. So overall, mu is not equal to 0. Okay, and here there is this bonds are highly polar. They are polar. Okay, now they are polar, but some amount of it is getting cancelled, but it is not getting fully cancelled because these dipoles are different. One dipole mu dash is because of the lone pair, mu is because of the fluorine. Okay, so they don't cancel each other, so there is some dipole. Okay, and over here you can see nitrogen is highly electronegative, and fluorine is also highly electronegative. So therefore the difference is very less. Okay, so the difference in electronegativity of nitrogen and fluorine is nitrogen is around 3 and fluorine is 4. So electronegativity difference is less. Okay, now coming to HBr. there is some amount of electronegativity difference between hydrogen and bromine, so it is polar. Okay, coming to the next one is hydrogen sulfide. Okay, so this is hydrogen, sulfur, and sulfur. So let's check the Z value. Sorry, I have drawn it wrong. Hydrogen, sulfur, hydrogen, hydrogen. So 6 electrons in the outermost shell, 2 monovalent atom. This is sp3 hybridized, and Z value is 4. So 4 minus 2 is equal to 2 lone pairs are there. So this is the bent shape like this. And the dipoles are getting added up, you can see. And there's also dipoles towards the lone pair of electrons. Okay. So the dipoles add up. So it is polar. Okay. Then I have CCl4, where CHCl3. Okay, and here you can see it's a strong dipole, and here they are not getting cancelled. Here they are getting added up. So here NF3 has a lesser dipole moment than HBr, which is lesser than H2S, which is lesser than CHCl3. Okay. So here NF3, although both are electronegative, nitrogen and fluorine, they get the electronegativity difference is very less. Okay. And HBr, the difference in electronegativity is there. In in H2S, they get added up. Okay. And the last one, it's a strong dipole. Okay. And because they are not getting cancelled. Okay, so this is the order, 16 points. So the B answer is right. Okay, second one. Coming to the 17th one, they are talking about statement A. Given below are the two statements, assertion and reasoning. Now the A statement is pH3 has a lower boiling point than NH3. So they are comparing pH3 and NH3. And the reason is in liquid NH3 molecules, they are associated through van der Waals force. But pH3 molecules are associated with hydrogen bonding. In the light of the above statement, to choose the most appropriate answer from the option below. Now, here, pH3 and NH3, we learned that in ammonia, they are associated with hydrogen bonding. So in pH3, they have only van der Waals force. Here they have hydrogen bonding because of the small size of nitrogen and electronegativity also. Now, because of which definitely ammonia will have a higher boiling point than pH3. Boiling point will be more. So that means A is correct. That is, pH3 has a lower boiling point. But the reason is not correct because here ammonia is having hydrogen bonding, right? Coming to the 18th one. Arrange the bonds in the order of increasing ionic character. Okay, increasing ionic character. So the one that has lesser ionic character will be placed first. So we will follow the Fajans rule. Okay. So difference in electronegativity if it is less. Okay. So here nitrogen, both are same molecule, so definitely it is non-polar. So it is having least amount of the ionic character. Then we have the next one is sulfur dioxide, which is non-polar. Yes. Again, we have the next one will be ClF3, which has here it will have some amount of the polarity because of high electronegativity of fluorine. Then I have K2O. Then I have lithium fluoride. Okay, so here lithium fluoride, this is between a metal and a non-metal, which will be ionic. Okay, and K2O also, it is between a metal and a non-metal. Fluoride is having a higher ionic character because the difference in electronegativity between lithium and fluorine is more than that of potassium and oxygen. Okay, so that is why we have placed them in this order. Right. Now, this is the order. Okay, so this is the order, so which corresponds to the third one. Okay, so always place the non-polar first. Okay, and then sulfur dioxide has some amount of polarity. More than that is ClF3, which is more polar because of the high electronegativity of fluorine. Okay, and then K2O, which is ionic, but it is less ionic than LiF because of the electronegativity difference between Li and F. Okay. Coming to the 19th one. Okay, choose the polar molecule from the following. So, polar molecule, we have CCl4. They are all in opposite direction. They cancel each other. Polar molecules, they have some amount of dipole. So here the dipole is 0 because they cancel each other. Carbon dioxide, a while ago, we just learned that we just saw in one of the question, it is 0. Then we have CH2. Sorry, I'll draw in a different way. This is also cancelling each other. So here also it is 0. And CHCl3 is not cancelling. So this is not equal to 0. So the answer is the fourth one. Okay. Coming to the 21st one. 21st is you have to check the hybridization. Which of the following has central atom is involved in sp3 hybridization? Okay, so over here, the first one is NO3 minus, half of 7 electron in the outermost shell, outermost valence shell electron plus there's a positive charge, so I have to add them. So I have 8 by 2, which is equal to 4. That means it is sp3 hybridized. Okay, now ClO2, sorry, I missed out BCl3. BCl3, half of 3 electrons. Boron has 3 electrons in the outermost shell. No positive, no negative, but 3 monovalent atom. So 6 by 2, which is equal to 3. 3 is sp2. Then ClO2 minus, half of central atom is chlorine, 7 electron in the outermost shell, no positive or negative. Yes, there's a positive negative charge, so I have to add them. No monovalent atom. So this is 8 by 2, which is equal to 4, which is sp3 hybridized. Okay, and then I have ClO3. ClO3, I have in chlorine, there are 7 electrons. So out of the 7 electrons, 1, 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6, 7 electrons. So it forms a double bond with oxygen. It forms a double bond with oxygen. It forms a single bond with oxygen, and there's a lone pair. Okay, so 1, 2, 3, 4, 5, 6, 7. Yeah. So there are 3 sigma bonds, and 1 lone pair, that is 4, that is sp3 hybridization. Yes, but you can see there is the for this also has the sp3 hybridization, so Z value is 3. It has sp3 hybridization. So our answer is how many species? 3 of them has the sp3 hybridization. Okay. Coming to the last set of questions, coming to 22nd. Okay, the number of following factors which affect the percentage of covalent character of ionic compound. Okay, so Fajan's rule is the polarizing power of cation, yes. Second one, B, is the polarizability or the extent of distortion of anion, yes. More it is distorted, more percentage of covalent character. Then C is polarizability of anion. Yes. So polarizing power is for cation, not for anion. So these 3 are A, B, C are correct. Okay. Coming to 23rd, the number of species from the following carrying a single lone pair on the central atom of xenon. So they need only the single lone pair on the xenon atom. So you know how to calculate the lone pair. First you calculate the Z value. So here you don't have to draw the shape, just we can quickly calculate the Z value for Xe F5 plus. So I have half of 8 plus number of monovalent plus minus 1 because there's a positive charge. So 8, 13 minus 1 is 12, that is 6. That is SP3 D2. We don't need the hybridization, we need the lone pair. So lone pair is Z is equal to bond pair plus lone pair. So here 6 is equal to 5 bond pairs plus lone pair. So lone pair is equal to how much? It is 1. So this is one of our answers. So I will write the answers here. Okay, so XEF5 plus. So this is one of our answers. So let's check if there are more. So XeO3, this is half of 8 electrons in the outermost shell, no positive or negative, no monovalent. So this is 4. So 4 is equal to how many bonds are there? 3 plus lone pair. So lone pair is equal to 1. So XeO3 is another answer for us. The next one is XeO2, half of 8 electron, the outermost shell, no positive or negative, no monovalent. So 4 is equal to 2 plus lone pair. Here this is not the answer because we need, here the lone pair is 2. We need for one lone pair single. So this is not our answer. Then F2. So F2, this is F and F. So 1, 2, 3, 4, 5, 6, 7. So this here, this is not our answer. Okay, there's no single lone pair here. Then XeOF4. Here half of 8 plus no more, there's 4 monovalent atom, no positive or negative charge. 12 by 2 is 6. So 6 is equal to 4 plus 1, 5 plus lone pair. So lone pair is equal to 1, 5 surrounding atoms. So XeOF4 is one of our answers. Then XeF4 half of 8 a valence electron plus 4 monovalent, no positive or negative charge. Here also 6. 6 is equal to 4 surrounding atom plus lone pair. Lone pair is 2. So this is not our answer. So these are our answers. Okay. I missed out something. Oh no. So these are our answer. So this XeOF4, Xe. Okay. Now coming to the 24th one. The 24th one, the pair of following, the pair from the following pair having compounds with non-zero dipole. That means they have some amount of dipole. Okay. So if you see 1, 2, this is the benzene ring. This is 1 and 1, 2, 3, 4. 1, 4 dichlorobenzene, and this is 1. If I label this as position 1, this is 3 dichloro. benzene. So here they cancel. Even though in here they don't cancel, but the pair should have a zero dipole. So this is our wrong option. Cis-butene and trans-butene. This is 1, 2, 3, 4, cis-butene. So this is our butene structure. So C cis-butene and trans-butene HCH3 HCH3. So this is the trans one. So here they are cancelling each other. Okay, so here also always the carbon with a double bond has higher electronegativity compared to this carbon. Okay, so here they are cancelling each other. So they have a dipole of 0. Okay, so this is our wrong answer. Then the next one is CH2, CH2, Cl2. So CH2, Cl2. So here they are not cancelling. So mu is not equal to 0. Okay, and CHCl3, we have drawn this in one of the previous questions also. Here also they are not cancelling. So here mu is not equal to 0. So this is our answer. Okay. And twenty-fifth one. In which of the following process the bond order increases from paramagnetic to diamagnetic? Okay, so first one is from oxygen to O2 plus. So here oxygen to plus. Okay, so here oxygen is 16. So sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2 equal to pi 2py2. So this makes 8 electrons, 8, 9, 10, 11, 12, 13, 14, 15, 16. So it is singly filled first. So this is our 8 electron, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay. So this is our oxygen. And this is already paramagnetic. Okay. When it forms O2 plus, so that means I have to remove this electron. So this is O2 plus. So this is also paramagnetic. So this is our wrong answer. Okay. Now coming to the next option, which is equal to O2. So O2 is, this is O2 and O22, O22 minus O22 minus. Okay, so O2 to 2 minus. So O2 to 2 minus is 2 electrons are getting added. So this is, it is increasing from para to diamagnetic. But let's check out the condition. The bond order. Bond order is changing. Bond order is increased. That also is happening or not. Let's check. Okay, so in one of the videos I had told you that when the number of electrons is 14, the bond order is 3. We checked for nitrogen. 14 is 3. If it is 15, it starts decreasing. If it is 16, it is 2. So for oxygen, the bond order is 2. And O2 minus, the number of electrons is, it is 1.5. So 18, it will be 1. So the bond order, we check number of electrons in bonding minus number of electrons in anti-bonding minus divided by 2. So bonding 2 to 4, 5, 6, 7, 8, 9, 10. So this is the star one. So 2 to 4, 5, 6, 7, 8, 9, 10. 10 minus antibonding is 2 to 4, 5, 6, 7, 8. 2 by 2 is 1. So it is for oxygen, the bond order is 2. For O2, 2 minus, the bond order is 1. This is also wrong answer because even though it is increasing from para to dia, the bond order is not increasing. So this I have told in one of my videos. The next one is NO. NO to NO plus. So NO, the configuration is sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. It is also having nitrogen is 7 plus 8 electrons, that is 15 electrons. So it follows the more than 14 electron configuration. So this is 8 electrons. Okay, then I have 2pz2 pi 2px 2 pi 2py2, so 8, 9, 10, 11, 12, 13, 14. And I have pi star 2px1 is equal to pi star 2py. There's no electron there. So this is what, it has an unpaired electron. So this is paramagnetic. This is for NO. Okay. Now NO plus, so let's calculate the bond order. Bond order here, if it is 15, 15 means bond order is 2.5. Okay. Now NO plus. In NO plus, this will be the same, 8 electron, 2pz2. So NO plus means how many electrons? 14 electrons, right? 1 electron is getting removed. So pi 2px2, pi 2py2, this electron will be removed. So this is diamagnetic. And diamagnetic And from paramagnetic, it is increasing to diamagnetic, and the bond order for 14 electron, it is 3. So both the conditions are satisfied. So our answer is the third one, NO2, NO plus. Okay, so students, that's all for today. We practiced some past paper questions. Okay, do practice the shapes and the geometry of different molecules. Okay, keep studying. Have a great day.